Nice to meet you.
How are you doing? My name is Chelsea. I work with AJ at Nevada Robotics.
Excellent. Yeah, I've
Awesome.
met about a couple of events we've had for down here at like UNLV and whatnot for
Awesome.
new teachers in robotics, and it's been a lot of fun to see that community grow a lot over the past couple of years. Obviously, with this year being a challenge with socially distancing education, and then how that impacts robotics, it's been it's been a lot of different things. So I'm sure we'll talk about that more into the call. But as it relates to getting into robotics, so myself personally, I have always kind of been a geek in liking technology. As a kid, I liked science kits and kind of doing little experiments in my backyard and all these little fun sciencey things that I noticed with the generation of students we have now is we don't have as many students that are really how do I say, engaged in the same level of physical real world manipulation. A lot of it's very much virtual based or you say it, digital media based in terms of using phones and computers to simulate experiences. For me, robotics was kind of this in-between gateway as a learning activity, but also something I thought was fun, of kind of taking what used to be garage tinkering and then tying in together all these cool new technological advancements that we've made through computing and applications of different programming, mainly programming, but also in terms of human and machine interfacing in order to complete some sort of task. And a lot of times as it relates to real world jobs and what you call it, industry, that's where I've seen a lot of growth as far as students who have these technical skills that they learn, not just to become roboticists. I don't have expectation that my students will become a roboticist, or myself. I'm not a roboticist, but I like technology. I like it in the way that it's done through robotics, where you have both the interactive physical elements of it, but you also have, of course, the digital programmatic elements of it that allow the student to have a very well-rounded education. And also, of course, building soft skills and interacting with students who they may or may not have otherwise interacted with through team challenges, project-based learning, that sort of thing. But yeah, I've always liked robotics. It's been a fun thing. I grew up in the age of RC cars, and so it just felt very natural. I work with students at Sunrise Mountain High School from ages around 9th grade, so let's say around 14, to some students that are 19 in my senior year students. And I have students who are both in my elective courses of STEM robotics, but also in my CTE courses of automation technology and manufacturing technology, which are currently both 3-year programs. And so I have a mix of students who come from each of those courses, as well as students who don't come from any of my own personal class courses. They just come after school for the club. We utilize a number of different platforms. VEX is a big part of our learning model, in the sense that the parts are more plentiful, they're cheaper, and I have, especially through recent grants and assistance from the state and different initiatives from like DRI, Tesla, and that sort of thing, from local companies as well, and you could say, not oversupply, but I would say an adequate supply of robot systems from both IQ and EDR, the plastic and the metal variants for my students. So I have equipment for my first years, my second years, and also for students in my CTE courses to learn about robotics and how it's becoming increasingly a part of certain industries, especially in, you want to call it manufacturing or advanced manufacturing, the greater use of what they call cobots or cobotics, where you have people working alongside robot machines, robot arms to complete some sort of task like you see in these car factories. But yeah, we utilize VEX a lot. We also have a couple of FIRST robotics platforms as well. We have a team at our school. And so we sometimes use our big robot for demonstrations, and also just teaching about how we integrate some of these more, you could say, at home or how do I say, consumer electronics components. For example, using a webcam we bought off from Best Buy on our robot as our camera system. A lot of students think that we have to buy some sort of technical thing or we have to create it from scratch. We could just buy stuff off the shelf and also just kind of program it to make it work with the system. We also have a couple of drones that we utilize, just teaching about sensors and more of like 3rd level or higher applications of technology. Obviously, the way I see it, drones are kind of like an aerial robot that you program, and then as the world continues to move and legislation moves as well, you might see a world where we have aerial deliveries of stuff like what Amazon's testing, right? How to deliver boxes with drones or multiple drones and that sort of thing. That's where the world, I think, is headed. And so that and a few other small robots, some small sensor robots and that sort of thing. But yeah, we have a number of different robots we use throughout the school year. So when I first started robotics, this was in my first year teaching in 2014. I kind of hopped on with an after-school robotics team that we had here as an assistant coach. I think for me, and what I was looking for previously, was an experience that would allow me to both learn but also to mentor. I think for myself, and thinking of my own education, being a product of public school, I grew up in a relatively modest community in California. It reminds me very closely, actually, of this school here, Sunrise Mountain High School, where I grew up in parts of central and northern California. I wanted an opportunity to give back, but also for something that I've always had interest in, which was technology and learning more in this quasi new world of robotics, right? Because I knew robotics as a kid from just playing with kits and toys and other fun things like that, and also tinkering around with small little projects, learning about microsensors and whatnot, and playing around with little devices and taking apart things and putting them back together. What I've seen it become now, which is this, how do you say it? It's just beyond this individual experience. You have a team sense of it. You have a school sense of it. There's this community that's outside just that of the school that you can compete, I would say more participate and share within. That to me is pretty exciting. There isn't much of that I remember growing up witnessing. It would be competitions and it'd be kind of pitted individuals versus individuals, or you could say school versus schools, but there wasn't a sense of this bond between competitors that I see within the robotics community on many different types of competitions, whether it be virtual only or in person, which my students have learned to enjoy, but obviously, overcoming nerves, being from our part of town where not many students have had the opportunities to go and compete with other students around the Las Vegas Valley, and some coming here from far away as well. That for me to witness that is something that's really exciting. And so for me, from that experience, my first year of teaching, and then now continuing on building a program out of it at our school, and now into a career development program, that's been the exciting part of just slowly moving the needle forward, if you will, of kind of creating what was an after-school group, exercise, a robotics team, to now a career preparation program, but also one that I think, for me at least, is tied to where the world is headed. Whether it be in some respects not as quickly as I anticipated, but in many other respects something that is going to be, for many industries, especially what we're seeing here locally, a rude awakening for certain types of work, jobs, skills, that sort of thing. The way I see it, if kids can learn things in high school, they might as well, right? Because they can save the time, the money, the headache over trying to figure out not just those elements of skills, but also what happens when they, graduate high school and they have all these extra responsibilities in life. And if they move out of home, they have to deal with things like finances and all these other difficult things that no one really tells them how to do. And so, or shows them how to do. And so I think that to me is, again, a part of just raising the bar as far as education. Coaching virtually right now. We have robotics meetings usually once or twice a week, depending on what we need to discuss and what we're working on. And so basically what it works is after school's over, virtual school's over, we'll have a meeting, and we'll have our different team captains and, students from around the different years that I have that will attend. And we have an agenda that we go through of what we're planning for the year. Right now, everything's been just preparations for incoming season-related stuff, so competitions. The difficulty, obviously, is we can't meet at school to discuss things. We can't physically work on anything. A couple of times I've shown students a tour of our shop and some old robots as far as ideas for planning the next robot for the upcoming competition. We're going to see what happens January as far as robotics competition. So for now, we're just evaluating the games that we've been tasked to prepare for this coming year. And what it comes down to is me having to either myself build the robot for the student remotely based off of their schematics, or depending on what my administrators thinks about as far as dropping off kits for students to work on robots. I know some schools are doing that. We're figuring that out as we speak. Obviously, a lot of it is up for discussion, and we want to be as safe as possible in the era of COVID. You know, for many coaches this year that I've spoken to, that's a tough battle to argue for or against, you know, as far as best experiences for students right now. I think for most teams, there's a lot of resources online, whether it be like programming aids, robotics, education videos, and that sort of thing. Virtual robotics, you know, we've done some competitions where we program online robots to do stuff, and that's fun. It's like video games basically for most of my students, but I guess it's not the same without having them be able to, you know, just actually touch the equipment, program it, keep testing it on game pieces like we usually do. So it's been different, but the adjustment has been made, and we're just going to do the best we can, even if our numbers aren't as great as, you know, previous years as we were anticipating. And, you know, myself and many other coaches, not just the teachers, right, that teach robotics, we're all trying to figure out the best way to keep our kids engaged while at the same time having a higher standard of learning. Because right now learning, if you ask any teacher, myself included, has been very challenging for students and also for educators. Everyone's kind of at this down period of time, trying to figure out how to make the most of this reality that we're living in, because there's many other pressing matters to some of my students and their families other than, you know, recreational robotics or these types of experiences. But we try to do the best we can with the students who are able to, and then, you know, create a roadmap, an avenue for when we do start up again, let's say next year in January, let's say we do a hybrid learning model where we can meet once a week, socially distanced, of course, but be able to work on robotics in a way where we can keep things clean, organized, and safe. And so those are things that, you know, we're constantly talking about. I try to read on online forums and that sort of thing. I chat with other coaches. Like we have a call this Saturday with other coaches to discuss this, you know, further. And this is for the larger robot platforms as well, how we actually do this, because yeah, there's a lot to unpack. You know, like I discussed, the biggest hurdle right now with many students is just not having access to the equipment. A big part of robotics is that trial and error, and also I think the stress, but also the excitement that comes from figuring out solutions to whatever it is they were working on. So if they're working on a mechanism to like lift up this block and drop it off into some chute, the plans for that, the 3D modeling and the design, that we can all do in distance learning. The difference obviously is we're not confined to a space like school, a workshop after school, where they're in one place for in many cases, many hours after school, right? Where they can build the piece, test it, and kind of go through the iterative design process to make it work. There are some platforms online that some teachers can utilize to do those types of robotics, but that oftentimes has a lot of limiting factors, like you don't account for friction and material wear and other software related problems that occur from any level of robotics, where you think things are going to work, you plan it out, and then you test it, and then something grave happens and you have to go and fix it. But that, you know, that's part of building that grit, right? That resilience to kind of solve problems as you go through. Students are, without that element, that physical interaction to robotics as it relates to the parts and the equipment, it becomes just like virtual robotics in games. It kind of feels like that in a way. Students are learning how to program. Some of them that are up to that task. Others are working on things related to, let's say, the robotics team, our team website, or other elements of the team, rewriting our club constitution, or figuring out marketing, recruiting for middle schools and that sort of thing. And so tertiary things to our central or our main focus during the year, which is to prepare for different whether it be projects within our class or our after-school program, to competitions that we, of course, are planning many months in advance to compete in. And so, yeah, for most students, they're kind of getting worn down by the fact that they can't really test what they want to test. So they'll complete assignments and try to learn from different videos and things that I suggest. But just like, you have the case with college students, right? You can show them the opportunities, but they have to, take those opportunities to further their understanding and learning. And I'll be honest with you, we're living in an era right now with education where I think many students are feeling this inundation of information or it becomes just a mechanical process of checking off the boxes for every class and every learning experience to get through the day, as opposed to being confined to a space where they're there to focus and finish whatever it is they need to finish with that particular program or class. And so you have students that are becoming growingly despondent to, just more work to do, right? They just say, I want to get my classwork done and that's it. I don't want to do any after school anything. I'll be a part of the team, for example, for a few of my students where they want to be a part of the team, but they don't want to be as engaged as, previous years where we would meet 6 days a week, and go over things and build robots and test. And I have to be, as a teacher that is trying to mentor them through this situation as well, I have to be very receptive and understanding of that. That's just the reality of what it means to work with youth, and also myself being a young adult, trying to figure out how to best mentor a younger person, how to work through this moment in life, because obviously robotics is not going to be the most pressing matter. So. Well, I think what's been very promising recently has been some different grant resources and funding resources for like team registrations, that sort of thing, for some of the local competitions. And we'll see what happens as far as national robotics competitions. That has been a very positive sign, because fundraising is a big part of robotics in order to stay alive year after year and kind of keeping up with whatever the trends are, as well as the competitions changing year after year. So having information related to potential sponsors and fundraising opportunities is always helpful for any team. Another thing as well is getting different robotics teachers together or coaches together as well, and engaging them through trainings. They don't have to be super long. Like I remember some in-person trainings being from like 8 in the morning to like 3 in the afternoon. It's always nice with paid lunch and breakfast, obviously, but that's expensive. I think having small trainings of 1 to 2 hours to go over whatever may be related to this robotics platform, or to a competition that's coming up with more details that we locally can answer. Because let's say, for example, VEX is going to talk about these kind of skills at home challenges where you just do the robot challenge. You buy the robot parts, pieces, and you do the competition in your house. How does that work when you have, let's say, 30 people on your robotics team and X number of kits? And then as far as who's going to submit what footage to represent your team, but you, the teacher, want to give equal access to all your students to participate. And so there's a little bit of work to be done as far as communicating with our local robotics teachers or coaches on how to execute their courses outside of what's already being done right now, which is using a lot of online learning through programming sequences, through videos on robotics platforms. Some teachers are able to send kits home. Students work on projects, submit videos, and that sort of thing. So I've written to a few first-year coaches and or teachers this year. A lot of it's been sharing curriculum and ideas. We have a robotics teachers group on Google for CCSD that I've seen a couple of teachers share resources and just the overall scope of the year, and ideas that they do have for the year. So this includes things like CAD programs, so 3D modeling and design, which is a big part of robotics, which is kind of fun. Students don't know how to draw in 3D. And if they have 3D printing at school, the teacher can 3D print stuff and make it for them, and maybe they can pick it up at some later time. To, of course, programming, learning basic coding languages, doing small challenges, and working their way up towards actually programming for robots, where I heard of a teacher at another school that would upload student code to robots that they have at their classroom, and then they can just see what it looks like in real life. So let's say, for example, I make a real life maze in my shop right around my desk here, and then I tell my students, here are the specifications, here's the locations, here are the measurements, design a program that will move a robot from point A to point C, doing something in between. That's a way to engage students. Obviously, if they're new, if a robotics teacher or coach is brand new, part of it's going to be figuring out, okay, well, what do I teach this year? How do I cover all the different standards? This being the weird year that it is, it's hard to cover every standard, right? It's going to be almost like a Passover of all the standards versus what happens usually in robotics class, which is like a consistent kind of covering of all the standards in different levels. So, of course, in the beginning of the school year, you kind of, bare bones, talk about all the different parts of how a robot works, from the building block stage all the way down to like programming sensors, and you just keep doing that over and over as you have different challenges for your students to do, on top of them learning about different terminologies and the different scientific or physical or engineering based concepts that robotics is predicated upon. And so it's going to be a combination for any educator in robotics, whether new or experienced, to figure out within the time frame that we do have with our students, which is oftentimes 2 or 3 times a week for maybe, let's say, an hour or an online call, to make the most of that learning experience. And I'll tell you, just from my own experience so far, it's been very tricky, because some students are more receptive to online learning than others. Some students are more hands-on, they learn better that way, or they would prefer that way at least. And so that's going to take me, as far as figuring out how to get a concept across, like how a sensor works. In real life, I show them how a motion detection robot can work, where I just show them a sample robot, I move a ball, the robot chases the ball, right? That's exciting to the student, it gets them interested. I do computer stuff where I show them a simulation of a robot following a ball. It's just not the same. And so those are some of the elements that every teacher has to figure out, that utilizing online free resources, videos, kind of create engaging exposure to robotics, and not just, of course, the classroom-based robots, but also advanced robotics, Boston Dynamics, all those crazy humanoids and animal robots they build, like stuff like that's really cool. And it gets, especially freshman students or sophomore students who are just barely starting out in robotics, an idea of what the future looks like in robotics and why someone would spend their time doing something crazy like spending hours on robots. So as I've noticed throughout a number of different states, and just from internationally as well, as far as where robotics education has kind of worked itself to, robotics represents this medium between the scientific disciplines, so mainly physics, which in my opinion, in many cases should be taught first, because it's more practical, and it seems to me to be a little more kind of tied into real life experiences than that of, say, biology or chemistry, which are a little more abstract and you can't see 95% of what you're studying, which oftentimes is like the small elementary particles and that sort of thing. Obviously, the fear is, of course, math requirement, and oftentimes physics comes with math, but there's just conceptual models to teach physics that research has gone and discussed at length. I've been to enough science and technology association conferences to kind of hear some differing opinions on how we should sequence the sciences. But that being said, so robotics, is a marriage of that, and also, the future, which is, of course, computer science, programming technology, automation, and applications. That is becoming more of the trend, right? Computer science education now becoming all over the place. One of the hottest, types of pathways that students are signing up for and schools are offering and looking for educators to teach. And so by combining those two, where you have this connection to the natural world, this natural inquiry, this excitement about learning how the world works that you have through physical robots, to now learning how to tie it all together in a computing sense, and then tie together all these extra elements that you learn about, whether it be pneumatics, fluid dynamics, that sort of thing, other technologies that are on the fringe, maybe more advanced cases. Robotics gives you a lot of flexibility to kind of take it as far as you want. And in the case of drones, right, the sky's the limit, right? I've seen some very interesting applications of drones where you can fly a mission, let's say over a mine quarry, and figure out how much of a particular in a job site, how much land they've excavated, to like 0.05% accuracy of fineness of data. And that sort of thing is real. It's happening. It's just obviously students being exposed to it in a way that they can see themselves doing these types of jobs and careers. That is what the future will become. How does a student, on the basis of a robotics education experience, gain some level of knowledge about the skills they'll need for the future, and not just treat it as a fun after-school endeavor that they do with their friends? It's just a club I do after school for fun with my friends. As you could see with many extracurricular activities, it can certainly be boiled down that way. And so the next frontier will be, of course, improving the educational model within robotics, curriculum-wise, platform-wise, and I don't want to get into all the nitty-gritty, pros, cons versus different platforms. But there's that, and also connecting it with industry, where the jobs that are going to be coordinated with what they learn in robotics class, or similarly robotics related courses, like my class is automation and manufacture. Those are very loaded terms because there's different levels of robotics utilized at different stages within there. Me having to figure out, okay, how do I teach a kid about advanced manufacturing when some of them have not even taken basic physics? I have to take down my curriculum and figure out, okay, well, I can teach them how to use a machine in a technical sense, but they're not going to understand why it works the way it does. They can push buttons. They can tell me how to convert some file, and then like I'm making these little chess pieces for fun here. How to make these little
Nice.
pieces here. Like I can get them to make me 30 of these, but I can't get them in some cases for some students to explain to me how this happens physically between the melting of the plastic to how it copies a 3D model and creates some sort of lattice structure to create the model. And so that's where we have to figure it out, right? We're in that process right now. What does industry want teachers to know, and then to teach their students? Where's that connection between the educational system, especially public education? I stayed a public teacher for a reason, because this is the future of how we change this country's education system for the better. There's just not enough money, and we can keep throwing more money at the system that continues to suck more money from our students, especially in post-secondary opportunities for more and more funds. And I don't want to get into all the educational, financing and whatnot. It just kind of boggles the mind when I think about the amount of money we spend in education. But that's really where we have to be honest with ourselves: is what are we actually teaching our kids for? Are we just giving them things to do and spending money on people and equipment because it's something nice? Or are we doing it truly because we plan on changing humanity for the better? Because we want to advance the human condition by teaching our youth how to be proficient with technology, because most of the world runs by technology, one way or another. We're not all become robots. We're not going to have human, Terminators or anything like that anytime soon. But yeah, how can we make what is an endeavor of fun but be aligned with an endeavor towards the advancement of humanity? I think that's ultimately what robotics wants its own discipline to be, right? To give it the legitimacy that you see in some of the natural sciences like physics, where you have many hundreds of years of, not thousands of years of research and of people dedicating their whole careers to advancing disciplines. Robotics kind of needs that, and what we have right now has been very promising, with more and more teachers and students and stakeholders and everyone liking it. I've seen multiple governors at different competitions and stakeholders and different companies and CEOs all go to robotics competition. That's been very encouraging to me, and the funding is certainly there. But again, what needs to be figured out is what's the relationship that we have to have between businesses, our schools, our higher education institutions like DRI, UNLV here, CSN, etc. How do we tie this together so that there's some sort of aligned pathway or a multi-pronged pathway where a student can see, okay, if I do this program at my school, here's what I'm headed next. And I don't like this whole just go to college, you'll figure it out mentality that we've kind of passed down to our kids on the basis of overstressed parents and right now financially hamstrung parents who oftentimes will defer the expertise to these colleges that will just say, yeah, just go through our general education program and then see where you land. The problem with that is the way the world works economically right now is just not, it doesn't fit that particular advice. And so for me, both on a moral basis and that of a pragmatist as well, I'm trying to figure out in a very rapid basis. I get to see it, right? I'm a teacher on the ground floor. I get to implement these things. How do I actually make that real? How do I take what I see on the ground? So, living here in Vegas, I can see the state of the tech community here, or the lack thereof, especially when it comes to startup funds and that sort of thing, or the types of jobs. Now they are coming. We have companies coming in slowly to our state and here in Vegas that are in manufacturing automation. But how do I actually communicate to my students that's real? So it's like, okay, well, I was just in a chat with this company here. They're looking for 30 apprentices by this date, apply. Like, that's the type of work that I want to be doing and I want to see more of. I think as a teacher, I'm already overloaded in and of itself of the mechanics of teaching and finding these opportunities and running the robotics team and a million other things that we do to make what we call our educational offering, wholesome for our students. And so I know I'm saying a lot here, but that's the hope that I have for robotics, is that it becomes an endeavor that ties together what I see to be the advancement of the people, of learning, of mankind, of what it means to truly advance, to make change happen in a technological sense that makes both learning sense, in the sense that you learn about all these different concepts that you wouldn't have otherwise learned about, but also tie it to a greater calling, a greater mission to better our planet, to better each other, as robotics has become this kind of communal, community-based activity, and not just this individual endeavor by someone, mad scientist tinkering in their shop.